In 2007, Chang'e 1, China's first lunar probe, soared into space, orbiting the moon for 16 months. Equipped with cameras and spectrometers, it meticulously mapped the lunar surface, sending back unprecedented high-resolution images and data. Building on the success of its predecessor, Chang'e 2 ventured closer to the moon in 2010. Its refined instruments captured even more detailed images, paving the way for future landing missions. Then, in 2013, China's first successful lunar landing occurred. The Chang'e 3 lander deployed the adorable U-2 Jade Rabbit rover, which spent months exploring the lunar surface, studying its geology and environment. China's Chang'e 4 in early 2019 marked the first soft landing on the moon's far side, a significant achievement. However, attempts by India, Japan, and Russia to replicate this feat failed, with unsuccessful landings and payload destruction. India's recent successful touchdown on August 23, 2023, as part of Chandrayaan-3, is the exception. In contrast, China's Chang'e 5 in November 2020 was an extensive, multifaceted mission, including an orbiter, lander, rover, and sample return vehicle, ferrying lunar rock samples back to Earth, the first such retrieval since the Soviet Union's Luna 24 in 1976. The lunar South Pole is now the center of a new space race, with nations competing to establish a presence there. Known for its abundant resources, this area is key for future human life on the moon. The Artemis program, led by the US with partners such as Canada, Japan, Europe, and 30 other countries, aims to make this a reality. They recently marked progress with a robotic lander's successful touchdown at the pole. Also in the race, China and Russia initially partnered to establish a moon base, but their collaboration has faced significant challenges. Russia's role diminished following its conflict with Ukraine and a failed moon mission in 2023, which revealed weaknesses in its space capabilities. Despite these setbacks, China continues to advance its lunar exploration capabilities, surpassing previous Soviet and Russian achievements. Their International Lunar Research Station coalition now includes Venezuela, Pakistan, the UAE, South Africa, Azerbaijan, Belarus, and Egypt, with ongoing negotiations to bring in more countries like Malaysia. The final 3 Chang'e missions, Chang'e 6, 7, and 8, will be launched from the Wenchang Space Launch Site in South China's Hainan Province, which is the mother port for China's space station construction and one of the most advanced space launch centers in the world. By May 2024, China is set to launch Chang'e 6. This mission will aim to be the first to collect and return samples from the dark side of the moon, consisting of 4 modules making up the fully robotic mission. A lander will collect about 2 kilograms, 4.4 pounds, of samples from 2 meters, 6.6 feet, below the surface of the Apollo basin and place them in an attached ascent vehicle to be launched into lunar orbit. The ascent vehicle will then make a fully autonomous and robotic rendezvous and dock with an orbiter, where the samples will be robotically transferred into a sample return capsule for their delivery to Earth. These precious samples, collected using a combination of scooping and deep drilling, will unlock secrets about the moon's formation, evolution, and potentially even the early solar system. China's next lunar endeavor, Chang'e 7, is set to launch in 2026. This comprehensive mission will comprise an orbiter, lander, rover, and min-hopping probe. Its primary goal is to scour the Shackleton crater's shadowed alcoves at the lunar South Pole, seeking the elusive water ice, a vital resource for sustained human presence. Chang'e 8 will follow suit, launching in 2028 and landing in proximity to Chang'e 7. The mission is expected to launch with a lander, a rover, and a robot. The robot, specialized in experimenting with 3D printing bricks from lunar regolith, will test the feasibility of using 3D printing technology to construct buildings for future moon base operation. These missions will culminate in the initial phase of China's meticulously outlined lunar expansion plan. The next phase in China's plans for the moon heralds a seismic shift, their first crewed moon landing. And to achieve this, China's lunar exploration program will have to focus on three main components, starting with the Long March 10th, a human-rated heavy-lift rocket. Unveiled in 2023, this super-heavy launch vehicle, codenamed Project 921 in reference to the founding date of China's human spaceflight program, is a powerhouse rocket and will propel the next generation of Chinese spaceships and the nation's future lunar lander toward the moon. With a height of 90 meters and comprising 3 stages, the Long March 10th will use 21 YF-100K engines at liftoff to launch China's next-generation crewed spacecraft and its future crewed lunar lander into space. The first stage of the rocket, along with its 2 boosters, each has a width of 5 meters and comes fitted with 7 YF-100K engines. The second stage also measures 5 meters in diameter and uses 2 YF-100M engines. Similarly, the third stage has a 5-meter diameter and is equipped with 3 YF-75E engines. The rocket is designed to carry a payload of 27 metric tons to lunar orbit and aims to be reusable through a wire tether system for booster core's propulsive landing. The next-generation crewed spacecraft, NGCS, another crucial component of China's lunar exploration plan, consists of a 3-person crew capsule and a service module for propulsion and power, similar to the Artemis program's Orion crew capsule. Despite being in the developmental phase, China has been conducting full-scale prototype testing since 2016 in preparation for lunar missions. Finally, the lunar lander is the third essential component of China's exploration plan. It is designed to transport 2 astronauts to the moon's surface and back to orbit. Moreover, a battery-powered lunar rover with a driving range of 10 kilometers will augment China's exploration capabilities. The initial Chinese lunar expedition will last around 6 to 8 hours, including exploration, sample collection, and experimental activities. All 3 components will come together. In 2030, as China plans to land its first crew of taikonauts, or Chinese astronauts, on the moon. Due to the payload limitation of the Long March 10th, 2 separate rocket launches are required. One rocket will carry the crew in the next-generation crewed spacecraft, along with oxygen, water, equipment, and other essentials for the mission, while the other will carry the lunar lander and lunar rover. Once launched, the vehicles will rendezvous and dock in lunar orbit for crew transfer before the lunar lander touches down on the moon's surface, where Chinese taikonauts will plant their flag, marking a significant step in humanity's cosmic journey. This milestone event strategically aligns with the 80th anniversary of the People's Republic of China. Undoubtedly, this anniversary provides a global stage for the Chinese Communist Party to orchestrate a momentous stride in humanity's cosmic saga, and this is just the beginning. This achievement serves as a precursor to the next phase, the International Lunar Research Station. This collaborative endeavor will see nations working together to build a lasting base of operations on the moon. The ILRS is expected to be completed in 5 missions throughout the 2030s, with the development of China's Long March 9th rocket being a crucial element. This rocket differs from the Long March 10th in that it has an increased payload capacity of 59.5 tons to lunar orbit and is not built for human transportation. The rocket is 114 meters tall with a 10.6-meter core diameter. This three-stage behemoth utilizes powerful engines generating a total thrust of 6,100 tons. The reusable first stage will be powered by 3,200-ton thrust rocket engines burning methane and liquid oxygen, while the expendable second stage uses 2 engines of the same type. The third stage will be powered by 4 YF-79 engines burning liquid hydrogen and liquid oxygen instead, each generating 25 tons of thrust. By 2031, the ILRS-1 plan includes setting up a command center, basic energy facilities, telecommunication facilities, autonomous operations, and long-term research exploration to meet the needs of their lunar infrastructure. In 2032, the focus of ILRS-2 will be on creating lunar research and exploration facilities for lunar physics, geological profiling, and lava tube exploration. While ILRS-1 and 2 missions will focus on setting up long-term facilities on the Moon, additional mission parameters include deploying various robots to collect rock samples. ILRS-3 in 2033 will see the establishment of a ground-penetrating radar system to study the lunar subsurface structure. It will also collect rock samples from ILRS-1 and 2 missions and return them to Earth. In 2034, the ILRS-4 mission will set up large-scale nuclear power stations on the lunar surface to support experiments and basic research in physics and life sciences. The final ILRS-5 mission, slated for 2035, involves establishing lunar-based astronomy and Earth observation capabilities. This collaborative effort positions China and its international partners strategically to advance their lunar operations. In contrast, while proposing the orbital gateway station, NASA's Artemis program lacks a comparable level of detail regarding their moon-based development plans. Historically, NASA's plans have often been affected by setbacks, modifications, and uncertainties, reflecting the agency's perennial oscillation between changing U.S. administrations. The perpetual shift in priorities underscores the challenge of sustained commitment and cohesive planning within NASA's agenda due to political fluctuations leading to a lack of consistent direction. Trump and Vice President Pence realized the risk of lagging behind China in this lunar race and reminded their allies to act fast. During the 6th National Space Council NSC meeting at Space and Rocket Center in Huntsville, Alabama, then Vice President Pence made a statement. The United States must remain first in space in this century as in the last, not just to propel our economy and secure our nation, but above all, because the rules and values of space, like every great frontier, will be written by those who have the courage to get there first and the commitment to stay. It emphasizes the rising stakes and the necessity of American primacy in space. NASA's Artemis 3, planned to be the first crewed moon landing mission, is slated to happen by September 2026 and has been called into question by the informed space community. Progress appears to be moving at a slow pace with the recent SpaceX Starship test flight failure. In 2023, SpaceX conducted 2 Starship test flights, one in April and the other in November. Unfortunately, neither flight achieved its goal of sending a Starship upper stage craft to Earth's orbit. While the SLS and Orion showed promise in a successful test mission, the Starship project has been fraught with complexity and challenges. NASA officials are considering changes to the mission parameters of Artemis 3, indicating growing concerns about the feasibility of a moon landing. Jim Free, a NASA Associate Administrator, has even hinted that Artemis 3 may proceed without a moon landing. The obstacles facing SpaceX are immense, from maneuvering the Starship into orbit to executing a propulsive landing of its massive upper stage back on Earth. Furthermore, SpaceX, NASA's contractor, is confronted with several pressing challenges in the near future, including the creation of an orbital refueling station and tanker ship system, and the development of a lunar-specific Starship variant to successfully land astronauts on the Moon. Given the intricate nature of these endeavors, safety must remain the top priority. China's objective of becoming the first nation to conduct a crewed moon landing in the 21st century is not an implausible feat. If all goes according to plan, China will have their first crewed moon landing by 2030. However, the achievement of this goal would have significant ramifications, particularly in global politics, particularly for Western powers. Despite the tremendous accomplishment of landing on the Moon, history has demonstrated that it has limited significance. The brief visits to the lunar surface during the Apollo program and the subsequent cessation of lunar missions underscore this fact. Furthermore, the absence of a lasting American lunar presence emphasizes the significance of mere moonwalks. In contrast, China has a more holistic vision. The Moon is presently the focal point of a renewed space race where the United States and China share a common objective while employing distinct approaches. While Artemis is committed to achieving the historic milestone of landing the first woman and person of color on the Moon by 2026, necessitating a disciplined approach that prioritizes both timeliness and precision. In contrast, China, through its ILRS program, adopts a systematic approach and works for the long game. Their blueprint involves the construction of the International Lunar Research Station, ILRS, an independent robotic installation that they plan to construct on the lunar South Pole in the 2030s. This strategic foresight aims to secure a sustained presence on the Moon, moving beyond ephemeral visits and ensuring that research activities are ongoing. While setting foot on lunar soil in 2030 will demonstrate their capability. China's decade-long emphasis on deploying robotic missions is a calculated move towards their ultimate objective. Although both nations pursue objectives such as resource access, technology testing, and the potential development of a lunar economy, Artemis prioritizes speed, while China emphasizes endurance. The moon race evolves into a competition not only for lunar surface dominance, but also for the most effective strategy for achieving a shared goal. Thank you for being part of our cosmic journey. And remember to leave a like on this video, subscribe to the channel, and ring the notification bell for comprehensive updates on all things aerospace and interstellar exploration.